Hello, my name is Arthur. I'm going to be doing my presentation on the question, is weather becoming more extreme, by looking at snow in the Swiss Alps. Main objectives, first, that I wanted to discuss that climate might be experiencing a shift rather than a stretch towards polar extremes, which I'll explain in a second what I mean by that. I wanted to use snow data to show that snowfall has not been increasing, not been more extreme with time, but rather has been decreasing. This is very important to the economy of Switzerland because they rely on skiing or tourism from skiing for a heavy portion of their winter economy. And then also it's important because snow has a high albedo, and the lack of snow in these regions could potentially contribute to a positive feedback loop, which would further reduce snow and further increase temperatures. So is the climate stretching or is it shifting? As you guys know, we've been seeing a considerable warming in our climate as we're approaching 2 degrees Celsius above the long-term average. Now, what I mean by a stretch versus a shift is in the event of a stretch, this bell curve, which represents the long-term climate, would be flattening out and extending on the sides, meaning you would be getting more of each extreme, more cold and more hot extremes. However, what we're seeing is an increase in the average, so a shift to the right, where we're getting more extreme hot weather at the expense of less extreme cold weather. So not just getting more extreme in general, but kind of a little bit more complex than that. So long-term snow climate trends of the Swiss Alps, studied by Latursner et al. Data was measured daily in two ways. First, you had total snow, and then you had new snow. So total snow was notated as HS, new snow HN. The reliability of the weather stations that were used, which you're seeing on this map, was very important. So they were divided based on how consistent their record was, which is this Q value here. Records that were very consistent are records where the station wasn't moved at all, and records that were not so consistent, values of Q0, were stations that might have been moved around either vertically or horizontally over time, making their data just less reliable for long-term analysis. So the Q0 values were omitted, and total you had about 140 stations for HS and about 120 for HN. This just shows the temporal growth of stations over time, with a notable increase in the 1960s when ski stations were being built for parameters. The single data were compiled and then averaged per snow season. The snow seasons were also measured in length based on how many consecutive days of snow were on the ground. Trends in new daily snow were observed, but then later omitted because they coincided with total snow so closely that there was just no need for them. Stations were also divided by altitude to reflect the effect of orographic uplift on precipitation in mountains. And then finally, the graphs and results were calculated with S+. So these results, you've got these maps which are colored based on the percent deviation from the long-term mean, lighter colors being negative values, darker colors being positive values. So from the 1930s to the 1960s, you see this progressive increase in snowfall over the Swiss country. In the 1970s, then a brief decrease, and it's important to note before I move on that in the 1960s, this increasing trend followed the brief cooling period that scientists thought was occurring in the mid-20th century. So back to the 1970s, cooling off, or less snowfall, 1980s, you see, interestingly, an increase in snowfall, although the industrialism was developing still. However, it's important to note that most of that was occurring at higher altitudes. And then finally, in the 1990s and up until this present day, just a severe decline in snowfall throughout the whole country. This is just another chart expressing what I just showed you guys, so percent deviation, the years, and you see the slight increase and then a sharp decrease, slight increase and then a sharp decrease. Snowfall in the Alps has generally decreased over time. This is one of the conclusions that were drawn by looking at the subdivisions based on altitude. So in higher altitudes where it's more likely to snow, you don't really see as much of an impact. The trend lines are relatively flat, and as you move towards these lower altitudes, you see this trend developing where you just have a slowly decreasing trend in snowfall, particularly after the 1980s towards the present day. So snowfall has generally been decreasing over time, which was very interesting because of the following key points. Winter precipitation actually increased. So although winter precipitation was increasing, snowfall was decreasing. This coincides very closely with my hypothesis that there has been a shift in climate rather than a stretch towards the extremes. So you're not seeing more extreme weather, you're just seeing more of one kind of an extreme weather and less of another. So there's this shift in climate rather than this stretch towards extremes, therefore proving that climate and weather has not been becoming more extreme.